Hi, and welcome to Mat140 Applied Math. We're going to discuss 12.2 counting principles. And so I wrote down kind of very sloppy, couple problems here. And then we'll try some more that are off the assignment. And you see that this is fairly simple to do. In how many ways can 4 coins be flipped? Well, what we use is sometimes what we call a slot method. There's 2 ways to flip the first coin. There's 2 ways to the second coin, 2 ways for the third coin, and 2 ways for the fourth coin. So if we multiply all those together, and that's kind of the idea behind it. The fundamental counting principle says we just multiply all these together, and that'll give us 16, I believe. So there's 16 ways that you can flip 4 coins. So the counting principle, the fundamental counting principle, put down fundamental. The fundamental counting principle basically says multiply your choices. Okay, suppose we went into a restaurant and they offered a complete meal. And this is on page 631, if you have the book. And if not, just follow along. So in this meal, you can have an appetizer, soup, entree, and dessert. But there's choices. You have 4 choices for the appetizer. You have 3 different types of soups that you can choose from. And you have 6 different entrees. Steak, chicken, whatever, I don't know, fish. And then you have 5 different desserts that you can pick from. So if you want to figure out the total number of combinations that you could form from these different items, we just times them all together. I have no idea what that meant. So let's go ahead and multiply that out. Let's grab a calculator. And we would simply multiply. Let's clear this out. Get something old in here. 4 times 3 times 6 times 5. Bingo. And you could do it in your head too. 360 different ways that we could form this meal. And if you wanted to give the waiter a hard time, you might change your mind. 359 different ways. And drive them crazy. Okay, so that's when sometimes when you go into let's say we go into a restaurant and we want to buy a Mexican restaurant and we want a combo. You see, there's a lot of different ways, to do this combo. There's say we have burros, and then on the burros we have how many different kind of burros or burritos if you want. There's green chili mixed, regular, red chili, so on. Let's say there's 4 different combinations there. And then you can have tacos. You get at least 2 different combinations. You can choose from enchiladas. There's probably 3 different choices there. Or tostadas. Maybe there's only 1. So if you wanted a combination of 3 things, just 3 things. First slot. Well, let's put a couple more down here. There's 4 different ways you can pick those burros, and then 2 different ways for the tacos, and 3 different ways for the enchiladas. So just using those and not using anything else, there's 24 different combinations right there that you could come up with. So you could see if you looked at the entire menu, how many different combinations you could form. All right, so let's answer some questions. I wrote some down here, and these correlate to the problems in the book. So let's take a look and see. On the first one, if there's 12 members on a newspaper, in how many ways can we choose an entertainment editor and a sales manager? They're all bidding for these jobs, and we only have 2 openings, entertainment editor, sales manager. You open it up to the staff. So what would happen here is there's 12 different people that want to pick this job. But once one is chosen, there's only 11 left. Sure, right on, go through the paper, I'm sorry. So it would be 12 times 11, which is what? 132 different ways that you could pick these people. That's a lot of people. You know, it could be John and Jim, or Jim and John, and so on. You could go pretty much crazy. Yeah. Okay, an equestrian club has 8 members. And how many ways can we select a president, vice president, treasurer? So again, I'm using kind of a slot method. We have a president, a vice president, and a treasurer. So the president, we can choose, there's 8 members, so any of these 8 could be the president. Then there's 7, because once he's the president, he can't be vice president also. So there's only 7 to pick here and 6 here. So if we multiply those together, 8 times 7 times 6, $336 different ways. That's a lot of different ways. See, that's why we don't want to list every combination. I mean, you'd be here for a long time writing all these down. So that's the key to these things. All right, let's try another one. Why is this going so crooked? I don't know. Here, that's better. Kevin wants to buy a new paddle board, fin, and paddle. And there's, let's see if I put a little light on here. This helps. Okay. And there's 10 different boards. I'm going to see if I can focus it better. I don't know. Anyhow, there's 10 boards he can pick from. So he wants a paddle board, 10 to pick from. He has 6 fins, pretty easy, and 5 paddles. So altogether, there's 300 packages that are available to him. Now, you might think it's all simple, but they get a little bit harder. And these problems right here are going to be a little tricky. Here you want to form a 4-digit number using the digits 0, 1, 2, and this includes, this is 3 dots mean 3, 4, 5, 6, 7, 8, 9. Okay, so all together, if we count all those digits, there's 10 of them. There's 10 digits there. 0, 1, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the number 0. 10 digits. Okay, and you want to form a 4-digit number, but certain restrictions have been placed. So on the first one, it says 0 cannot be in the first digit because then it wouldn't be a 4-digit number. Huh? So we can't use a 0 here. So we only have 9 digits. Now, some people get confused and they think we're putting the number 9 in there. No, it means we have 9 choices. This is the number of choices. Now, in the other digits, they can be repeated. So we could use any of these numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 choices here. This is the number of choices that we get to pick from. 10 here and 10 here. Just like on this first problem right here, or this problem we had done up here. There were 4 choices for appetizers, 3 for soups, and so on. So there's 9 choices for the first slot, 10, 10, 10. So if we multiply that together, we get, what is that, 9,000? So there's 9,000 choices. Okay, this one's a little tricky. A number must begin and end with an odd digit. Digits may not be repeated. So let's take a look at this. This one is tricky. The number must begin with an odd digit. Out of the numbers 0 through, let's just jot them down, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I write those down, how many are odd? 1, 2, 3, 4, 5. So you have to kind of reason out. There's 5 here. And let's suppose we took the number 1 right there. We chose that for this spot. Then it says it must end with an odd digit. So if we took the number 1, now there's only 4 digits left to end with. So it must begin with an odd digit and it must end with an odd digit. So we've already used 2 of those digits. Say we use the number 1 and the number 3. How many digits are left now? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 digits left. For this slot right here. And then there's 7 digits left for the next slot because we can't repeat. So we use 2 of the numbers up, which leaves us with only 8 digits left, and then 7. So this one's tricky. You want to figure out the first digit and the last digit. Then you can fill in the other digits. So there's 5 choices for the first, 4 for the last one, 8 for the second one, 7 for the. So these are what we call choices, not the actual numbers that we would put in there. So if we times that all together, I believe it comes out to 1,120. So that would be our answer. Okay, the number must be odd and greater than 5,000. It must be repeated. So let's take a look at this one. The number must be odd. Okay, so to be odd, it would have to end with a 5. I mean, it would have to end with one of these odd numbers, 1, 2, 3, 4, 5. It has to end with not a 5, but it has to end, there's 5 choices to put in there. Again, we're looking at choices. There's 5 choices there. And it says the number must be, where does it say? The number must be, begin with an odd digit. Wait, I'm looking at the wrong one. The number must be odd and greater than 5,000. It's got to be greater than 5,000. So it could be 5,001. It has to end with an odd digit though. And it could be 6,000 something or other, and it could be 7,000 something or other. And 8,000, 9,000. It's just got to be greater. So there's 1, 2, 3, 4, 5 choices that we could use for the first number. There's 5 choices. Maybe one of those we use for the last number, I'm not sure. But I would assume there's 5 choices for the first one and the second one. Then digits may be repeated. So that if you had used an odd number here, you could still use an odd number here, right? So if you use any of these numbers, 1, 2, 1, 3, 5, 7, 9 here, you could still use them here. But you can only use 5, 6, 7, 8, or 9 to start off this number. So there's only 1, 2, 3, 4, 5 numbers to choose from. Now here you can choose any number you want. So there's 10 choices and 10 choices here. So if you multiply this all out, and you calculate 5 times 10 is 50 times 5 is, times 10 is 5. 5 times 10 is 50, 500, 2,500. 2,500 choices. So these are kind of a reasoning problems that you have to kind of do. Let me look at a couple more here and let's see what we can do. Okay, last one. The number must be between 5,000 and 8,000, and digits cannot be repeated. So the first digit could be a 5, a 6, a 7, but not an 8 because it's got to be between those. It can't be an 8. So in the first digit, we can put a 3. There's 3 choices. The digits cannot be repeated. Well, let's think a little bit on this. What about the last number? If the digits cannot be repeated, there's 9 numbers that we can use for the last one, right? So sometimes I go for the first number and the last number. So now we've used 8 choices up, 2 choices up, and there were 10 choices to begin with. So we used 2 of them up, so there's 8 left for here, and they cannot be repeated. So there's only 7 choices for here. So if the number has to be between 5,001 and 8,000, we had 3 choices, because we can go up to 7,900, and we can't repeat the digits, so 80, something or other, 7 or 6 or something. Okay, but we can't go up to 8,000. So 3 here, 9 here, 8 and 7. Let's see what that comes out to be. 3 times 8, times 7 times 9. 1,512. 1512. So these are kind of logic problems in a way. You have to think about them a little bit. You might want to try those again. How many ways can you choose answers to an 8-question true-false quiz? There's 8 questions. And they're true-false. So there's 2 choices. There's 2 choices here. They're all independent of each other. 2 choices, 2 choices, 2 choices, 2 choices. 1, 2, 3, 4, 5, 6, 7, 8. We can multiply these 2 times each other, or it's actually 2 to the 8th power. You can think of it that way too. 2 raised to the 8th is 256. Or you can multiply, because 2 to the 8th means we have 8 2s. 256 ways. A license plate, this is number 24. It says something about a certain state has a license plate. It has 2 letters and 3 digits. And they can be repeated. Now, I'm sure there's certain letters you can't use, but we're going to assume they can use any letters. So what are we going to do with the letters? How many letters are there in the alphabet? Well, there's 26. You can sing your alphabet if you want. 26 for the first, 26 for the second. And then 3 digits. The digits, again, are 0 through 9. It sounds like 9, but there's actually 10. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, which gives you 10. So there's 10 possibilities here, 10 here, and 10 here. So how many combinations? See, you wouldn't want to write every combination down. 26 times 26 times 10 times 10 times 10. Pretty big number. 676,000. 676,000 ways. Double checking my work here just to see. Okay, 3 letters, 2 digits. 3 letters, 26 choices, 26 choices, 26 choices, 2 digits. If the digits could not be repeated, then it would be 10 times 9, but they can be repeated, so it's 10 times 10. So 26 times 26 times 26 times 10 times 10. 1,757,600 different ways. So you want to have a little fun with these. I did some of the problems, try some other ones, or try these again. And now that you have some kind of solutions to them, you can look at them. One last problem that's kind of difficult. This is this problem on 633 in your book. Let me go over this one real quick. A clean sheet of paper here. Okay, it says, Professor Bartlett teaches an advanced cognitive psychology class of 10 students. So there's 10 in the class. Let me put something underneath here. Sometimes this pen bleeds through. So there's 10 in the class. And she has a visually challenged student, Louisa, who must sit in the first row next to her tutor, who is also a member of the class. If there are 6 chairs in the front row, okay, let's put 6 chairs. And how many different ways can he assign the students to these? Well, unfortunately, Louisa and tutor have to sit together. So Louisa and tutor could be here. That's one choice. Louisa and tutor could be here. That's 2 choices. Louisa and tutor could be here. That's 3 choices. Louisa and tutor here, 4 choices. Louisa and tutor here, 5 choices. They get 5 choices. But what if the tutor wanted to sit first? Tutor TL, 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 5 more choices. So what we could think of is that these first 2 chairs, there's 10 ways you can assign Louisa and basically to the whole row, but they're occupying up 2 of the chairs with 10 different ways of doing this. They could sit anywhere in this row, but there's 10 different ways we could put them in the row. That leaves only 1, 2, 3 slots, 4 slots left to the rest of the class. We used up 2 of the students, so now there's only 8 students left to put into this slot. So let's assume that we just threw them in the first thing, but they used up 10 of the slots, 7 here, 6 here, and 5 here. So if we put these, no matter where we put them, they're using up 10 combinations just for those 2 people. The rest of them doesn't really matter. So we got 10 times 8 times 7 times 6 times 5. Let's see what that gives us. 10 times 8 times, let's start over again. 10 times 8 times 7 times 6 times 5 times, that's it. 1, 2, 3, 4, 5. No. Yeah, because these occupy 2 seats. So 4 and 2 makes 6. Okay, so that gives us 16,800 ways. And you can look at this problem in the book and kind of analyze it, but that's how they did it. They're kind of thinking that this would be LT, or this could be LT, or this could be LT, 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 5 choices. Or it could be TL, 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 TL. Depends on what side the tutor wants to sit. So, or Lisa wants to sit. So there's 10 choices between these 2 people. And then the rest of the choices are for the rest of the class. They're not finicky about where they sit. So we can just put them in any of these 4 remaining seats. So I hope this helped you a little bit, and try these problems. They're kind of logic. That's what this whole chapter is kind of about. And it is a little tricky.